इस क्वेश्चन के अंदर हमें दे रखा है एक साइक्लिक प्रोसेस फ्रॉम के टू एल, फिर एल से एम, फिर एम से एन और एन से वापस के। तो हमसे पूछा गया है कि यहाँ पे आइसोकोरिक प्रोसेस कहाँ कहाँ हो रहा है। तो आइसोकोरिक का मतलब क्या होता है, हमारी जो वॉल्यूम है वो कांस्टेंट रहेगी। अब प्रेशर जो है वो हमारा वाई एक्सिस पे है, वॉल्यूम हमारी एक्स एक्सिस पे है। तो हमें ये नोटिस करना है कि कहाँ हमारा जो एक्स कोऑर्डिनेट है वो चेंज नहीं हो रहा, लेकिन वाई कोऑर्डिनेट चेंज हो रहा है। यानी कि जहाँ पे भी हमारी लाइन होगी पैरेलल टू वाई एक्सिस पीवी ग्राफ के लिए, वहाँ पे हमारा प्रोसेस क्या होगा, आइसोकोरिक। अब अगर हम एन से के का प्रोसेस देखें तो यहाँ पे प्रेशर तो बढ़ रहा है, हमारा वाई कोऑर्डिनेट कॉन्स्टेंटली इंक्रीज कर रहा है, राइट। लेकिन हमारा जो एक्स कोऑर्डिनेट है वो वहीं का वही है। एंड सेम गोज फॉर प्रोसेस L2M। ये भी एक आइसोकोरिक प्रोसेस है बिकॉज यहाँ पे भी वॉल्यूम के अंदर कोई चेंज नहीं हो रहा। तो हमारा करेक्ट ऑप्शन कौन सा होगा, N to K and L to M, यानी कि सेकेंड ऑप्शन।
Hello everyone. So in this question it is given a fixed mass m of a gas is subjected to transformation of states from K to L to M, N and back to K as shown in figure. A plot of volume versus pressure is given in this case and it is subjected to 4 transitions from K to L to M, N and K. So we have to figure out what is happening exactly in this transformation. So if you see the question, it is said that the succeeding operation that enable this transformation of states are heating, and cooling. So what happens is, assuming this transitions, the gas which we have as ideal gas and behaving all the ideal gas properties, so we can say that PV is equal to nRT, right? Given the mass is constant and R is always a constant, N value, that is amount. So amount will be related to mass, and amount and universal gas constant is universal gas constant, that is R value, are constant. So from this we can conclude that PV is directly proportional to temperature. Okay. So from this, if you see the first process which is happening from K to L, so I will write down from K to L, you see the volume over here is constant and pressure is decreasing and pressure is increasing, right? Volume is constant and pressure is increasing. We know the condition that we have is PV is directly proportional to T. Since volume is constant, this is constant, and the pressure is increasing, this means that temperature is also going to increase. So we will have to increase the temperature. This means it is a heating process. So the first process is heating. Now from L to M, if you see the plot from L to M, what is happening is the volume is decreasing, but the pressure is constant. Here we can write volume decreasing, but pressure is equal to constant. So again the relation same, PV directly proportional to T, pressure is constant K, volume is directly proportional to T. Since volume is decreasing, so the temperature is also going to decrease. Hence we can say it is a cooling effect. Correct. Moving forward to the third transition, that is from M to N. M to N, what is happening? The pressure is decreasing, the volume is constant. Pressure is decreasing. I'll write down from M to N, pressure is decreasing and volume is constant. Again the same relation, PV directly proportional to temperature, where pressure is decreasing and volume is constant. So since pressure is decreasing, temperature is also going to decrease, right? Because there is a direct relationship. Hence we can say it is again cooling. For the final transition, that is from N to K, right? N to K, what is happening? If you see carefully, the volume is increasing and pressure is constant. I'll write down from N to K. What happened? Same, the volume was increasing, but pressure is equal to constant in this case. The relation PV directly proportional to T, where P is constant in this case, and volume is increasing. So temperature is also going to increase, and hence we can conclude that this is a heating process. Now, if you see what we got for first process, we got heating, then for second process cooling, third process cooling, fourth process heating. So this will be the answer for this question. Wherever heating, cooling, cooling, heating is present, that option is the correct option. If you see option number A, it is heating, cooling, which is not true because we need something HCCH. Here we have cooling, heating, heating. Again, incorrect. Third, we have heating, cooling, heating, which is absolutely correct. And the final one, cooling, heating, cooling. This is also incorrect. So the only correct option is option number C. Thank you.
Hello friends, welcome to DoubtNut. Our question says, match the thermodynamic processes given under column 1 with the expressions given under column 2. So there are two columns, column 1 and column 2. We have to match the expressions in the column 2. So first question is, freezing of water to 273 Kelvin and 1 atmosphere. Okay. During the freezing of water at 273 Kelvin and 1 atmosphere, the entropy change of the system is 0. Entropy change of the system is negative, and the free energy change is 0. Delta G is 0. So our option A will go with R and T. Okay. During next is expansion of 1 mole of a gas, ideal gas, into a vacuum under isolated conditions. During this, what happens is no heat is exchanged. Heat change is 0. No work is done. W is 0. And there is also no change in internal energy. Delta U is also 0. So our option B will go with P, Q and S. In the third option, mixing of two equal volumes of two ideal gases at constant temperature and pressure in isolated container. During this also no heat is change occurs, no work is exchanged, work done is 0, and the internal energy is also 0. So our option C will also go with P, Q and S. During the last option, reversible heating of hydrogen gas at 1 atmosphere from 300 Kelvin to 600 Kelvin, followed by reversible cooling to 300 Kelvin at 1 atmosphere. During this, what happens is there is no heat change, Q is 0, there is no work change, work is exchanged, W is 0, there is no change in internal energy, the delta U is 0, and there is also no change in free energy, delta G is also 0. So our option D will go with P, Q, S and T. Okay, these are the 4 options matches according to the given. Thank you. Hello friends, welcome to DoubtNut. Our question says, match the transformation in column 1 with appropriate options in column 2. So our first option is CO2 in solid state changes into CO2 in gaseous state. Okay, CO2 is solid is changing to CO2 in gas. Okay, as it is changing from solid to gas, it is a phase transition. So our A will go with P, and it is only the phase transition is the sublimation is going on here. Okay, and sublimation is endothermic. So delta H will be positive. So it will also go with R, and as gases are more disordered, so delta S will also be positive. So it will also go with L. In option B, we have CO3 solid changes to CO solid and CO2 gas. Okay, so CaCO3 from solid is changing to CaO in solid plus CO2 as gas. Okay, this is a chemical decomposition but not a phase change. This is a chemical decomposition. Okay, and the thermal decomposition occurs at the expense of energy, and hence it is an endothermic process. So delta H will be positive, and it contains the gaseous product, so disorder will be more, and hence delta S will be greater than 0. Okay, so our option B will go with R and S. In the third option, we have 2 times hydrogen is changing to hydrogen gas. Okay, here it is, 2 times hydrogen is changing to hydrogen in gaseous form. Okay, a new HH bond is being formed, and hence delta H is less than 0. New HH bond formed. HH bond formed. So delta H will be less than 0, and as the product is less disordered than the reactant, delta S is also less than 0. H2 is less disordered. Okay, so delta S is also less than 0. So the option C will go with only T, that is delta S is negative. And in the last option, we have phosphorus white solid changes to phosphorus red solid. Okay, in this phosphorus white in solid is changing to phosphorus red, and it is also in solid state. Okay, both these are allotropes. So this is a phase change as well as the allotropic change. This is phase change and allotropic change, okay, and hence red phosphorus is more disordered than white phosphorus, so delta S in this case is also less than 0. So your option D will go with P phase change, allotropic change Q, and delta S is negative, that is T. So your correct options for A, B, C, D are these. Thank you.